Hello and welcome to my Revit tutorial today. I will show you how to draw in this steel structure with a shear wall in the middle of it. So in this tutorial, I'll be mainly focusing on how to draft the general elements of this building, and in other tutorials, I will show you how to draw in the steel connections, how to detail the shear walls, and so on and so forth. So without further ado, let's get started. So first things first, I will head to the File button over here and click on the arrow over here and click on project. So we'll choose the default structural template over here and click on OK. So first things first, before you begin drawing, it's always a good practice to check the units that you're using. So head to the Manage tab over here and click on Project Units. So the project units pop-up window will emerge, and there is this drop down over here that can cycle between the different disciplines. So from the start, you can see that the common discipline has all its units in SI units over here. So the main unit to look out for in this tutorial is to check the length. So right now we're using millimeters over here, and you can include the unit symbol, so that will help us to determine that we are still using the same units that we started with. And if you click on the discipline drop down and head to the structural discipline, you can find all the other units that are typical for engineers over here. So as long as you've already set the length and angle and area correctly for your purposes, it should be fine. So just click on OK. So let's proceed to the next step, which is to draw in the grid lines for the project. So if you look in the previous file over here, if I were to open a plan view, I have a grid that is 4 meters apart along the left to right, and top to bottom it's spread out by 6 meters. So let's draw in the grid lines over here. So head to the structure tab, click on grid, and I will draw in the first one over here like so. And to speed things up, choose the pick lines option over here and key in the offset in millimeters as we've set before. So I will key in 4000 millimeters over here for 4 meters. And I'll click 1, 2, 3, 4, 5. So let's quickly check back over here. So I have 1, 2, 3, 4, 5, 6. So one more. Structure tab, grid. Like so. And I will just quickly rename them over here. So let's draw in the grid lines that are going left to right. So let's click on the grid button again. And I will draw the first one over here. But before drawing the next few, I will key in one over here. And I have grids 1 to 4. So they're spaced at 6 meters apart. So proceed to the structure tab again, grid. Choose pick lines. Key in 6000 millimeters over here. And I'm not sure if you've noticed this, but the following grid is named number 2 after I changed it from an alphabet to number 1. So that's one neat trick to know about Revit. So I have 1 to 4 over here as in the previous drawing. So now that we've already set up the building grids over here, we can dimension them just for our own reference. So click on annotate over here, click on align, and just click on this grid line over here to the next one, and you can immediately see the dimension like so. And you can dimension the whole building width like that. And if you notice, when you want to place another dimension line, you can snap it to the previous one like so. So that's a neat feature in Revit. And you can just do it continuously like this to form one group of dimensions like this instead of individual ones like so over here. And that's pretty much the basics for dimensioning. So let's move on to the elevation view to check the levels over here. So let's extend these lines further down in the east and north elevations over here. And proceed to the structure tab once again to click on level over here. And choose the pick lines tool and change the offset from 0 over here to, let's say, 2 meters over here. Okay, so this is also in millimeters, sorry, so 2000. And just one quick tip to know about the pick lines is that if you hover slightly below your existing level, it will draw the new level underneath it. If you hover it above the existing level, it will draw the new level above it. So that's one thing to note. So now that we've already drawn in the footing level over here, I will just rename it as top of footing. Let's just quickly drag these grids up. So let's draw the following levels from level 2 all the way to 5. And just go back to the structure tab over here, click on level, click on pick lines again, and type in 3 meters over here, 4 and 5, and 6. Okay. So now that we've already drawn in the levels for a structure, let's say for example, you'd like to change the height of one level. All you need to do is select on the FFL tag over here, click on it once and once more, and you can key in any value you want. So for example, I want this level 2 to be 4 meters from the level 1 FFL. I can do it like this, for example. And let's say I want to do the same thing for level 3 as well. Make it 4 meters all the way up to, hold on. So let's make this 16 here and 12 here, for example. So that's pretty much the basics on levels in Revit. So let's move on to the plan views over here. So now that we've already drawn in the levels for our tutorial over here, so let's move on to the structural plans. As you can see, by default, we only have plans for level 1 and 2. So let's create the plans for all the remaining levels 3, 4, and 5 and top of footing over here. So let's proceed to the view tab over here and click on the plan views drop down and select structural plan. Alternatively, if you are doing architectural disciplines, you can do RCP over here or a regular floor plan. But for this tutorial, we'll be focusing on the structural plan over here. And you will be greeted with this new structural plan pop-up window, and you can create a structural plan for all the remaining floors that don't have a structural plan. So just click on OK. And we've just created the structural plan for level 3. So let's quickly do the same thing for the rest. I forgot to select all of them just now. So there we go. We've already created all of them. If you notice something odd over here in level 3, you don't see the grid lines 1 to 4. You can fix this by going to the elevation view. And you can see for yourself that the grid bubbles for 1 through to 4 don't reach the top level over here. So let's extend this all the way up. And if we go back to level 3, we can see that they appear once again. And you might be wondering, why did I just choose the east and north elevation? Well, in Revit, if you were to edit the east elevation, it will correspond to the west. And if you edit in the north, it will correspond to the south as well. So that's why you don't have to worry about all 4 elevations here, just east and north, and you can pretty much make it visible in all the plan views. So that's pretty much it. So let's move to the 3D view over here by clicking on this house. So these are the grid lines that we've set up in the plan views, and these are the levels that we've set up in the elevation views. So let's proceed to top of footing over here. Proceed to the structure tab, and let's draw in our pad footing. So click on isolated over here, and you'll be greeted by this default family over here. You can select the edit type button, and you can see the foundation thickness, width, and length. So let's say I want to edit this width over here and foundation thickness, but I don't want to overwrite the values over here for this specific type. I can click on the duplicate button here and just type in, let's say, 2.5 by 2.5 by 700 over here. So 2.5 meters by 2.5 by 70 centimeters over here. So, or 700 millimeters here. And I can key in the values that I've typed for the label. And I can click on apply and OK. And it might seem repetitive to individually place each of these pad footings, so there's a faster way of doing it. So click on isolated foundations here, and so you will see this multiple section over here. Click on add grid since we don't have any columns over here, and select your grid over here. Click on finish, and in the 3D view you can see that all the pad footings are placed at the grid middle. So just by using the add grids function, we can quickly draw in all these pad footings such that the middle of each pad footing aligns with the grid line intersection over here. So that's the first part done. So to draw in the pedestals for the base of the structural steel column, what I used was a structural column itself that's made of concrete. So back to the top of footing plan view, click on the column button over here, and you can see we have a drop down with multiple options here. But before we draw anything, make sure that we are using the correct settings here. If you're using depth, it means that you're drawing from this level downwards. If you're using height, it's drawing from this level upwards. So I will draw from the top of footing level to level 1 over here. And I will just quickly import a structural column that's square. And I will choose a 60 by 60 centimeter column over here. And again, I can choose the add grids option, click on finish. So that's pretty much it for our pedestals over here. So let's quickly draw in the tie beams and our slab. Then we can proceed with the steel structure itself. So let's head back to top of footing over here. Or better yet, let's move to level 1, since we want the tie beams to be in this level. So click on beam over here and click on the rectangular beam over here. It's concrete. And you can choose on grids over here. Select all the grids. Click on finish. And let's look at what we've done over here. So we've already drawn in all the tie beams, pedestals, and footings. You can draw in the slab right now. So let's head back to level 1, go to structure, and click on floor, structural. I will choose a in situ concrete slab over here. The level is set at level 1, and I will choose the rectangle draw tool over here and just draw from the middle of this column to the middle of this column over here, and click on the green arrow over here. So we've already drawn in the slab for our first floor over here. The slabs for the upper floors will not be same family, since they will have a metal decking, a bond deck, or whatever you might call it in your place of practice. So let's head back to level 1 over here. Click on column and You can see that we only have universal beams over here. I don't have any sort of universal column family loaded in. So I'll just click on load family over here and go back a few folders and click on structural columns here, steel. You can find a universal column over here, for example. Click on open. And let's say a 5-story building like this. Let's just say it's sensible to have a 305 section, for example. And once again, make sure you have the height option selected. Click on add grids and finish. So that's pretty much the first step in getting our steel superstructure done. Let's move on to level 2 and draw in the beams for our second floor. So click on beams, click on the drop down. You have quite a few universal beam sections here, so we can use the 300 section over here for the 6-meter spans, and we can downsize for the 4-meter spans, for example. So click on grids, click on the longer 6-meter spans over here, like so. And I can choose a smaller section for the 4-meter section. So back a few folders over here, go back to structural framing, click on steel and universal beam over here, open. So we can use a 250 section over here, for example, and choose add grids like so and click on finish. Now you might have noticed something over here. If you were to go into the elevation view, the top flange of the beam is exactly flush against the second level over here, which is not correct. So in order to correct this issue over here, we need to go back to the 3D view, select everything over here, click on filter, check none, click on structural framing primary over here. And unfortunately, you can't segregate between the steel beams and the concrete beams over here. So we just have to hold the shift button and left click so that we can only select the steel beams over here. What we will do is apply a start level offset over here. So if your slab thickness is 12 centimeters, key in 12 centimeters. If it's 15, key in 15. So let's say in this example, it's 15 centimeters over here. So I will key in this offset at the start. Oh, hold up. It's still in millimeters, so minus 150, minus 150. And heading back to the elevation view, we can see that we've made the space for the slab over here. So that's the correct way of modeling. So back to level 2 over here, and let's change this to a fine detail. Click on floor and choose the 16 centimeter slab. Click on edit type over here, duplicate it, and let's change it to 150 millimeters over here. Click on edit, and I will change the concrete thickness to 150. Click on OK and OK once more. So click on the rectangle drawing tool over here. I will draw from the corner of that column to this column over here. And the slab direction will be from A to G. Click on finish edit mode over here. And in the 3D view, you can't see the profile of the chorus com floor over here, or the bond deck. You can only see that in the elevation view over here. But if you were to use a coarse level of detail, you won't be able to see it. You can only see it in the medium to fine range over here. So that's one thing to note. So now that we've already drawn in the slab, you can see that the beams are drawn in with these dashed lines over here. That's typical. And one thing I forgot to mention is that we need additional secondary beams over here. So let's do it the more efficient way, and that's to use the beam system over here. Click on Sketch, and you can draw it from the inside span over here, inside span over here, and click on Finish Edit Mode, and that should draw us secondary beams like so. So let's hide the slab and let's try to fix what we have over here. So we don't have duplicates over here, so that's a good thing. And in the structural beam system, you can actually adjust the spacing here. So if you recall from earlier, the span here is 6 meters, so let's try to make it 2 meters apart. So let's dimension this from center to center. It's 1685, 1829, and 1829. Okay, so let's try and fix that. So if you're having difficulty selecting the structural beam system here, hover over one of the beams over here and press tab, and you can select it like so. And you can choose a different layout rule, whether is it fixed distance, fixed number, maximum spacing, clear spacing, so on. So let's key in 2 meters over here, like so. And that's pretty much fixed up the secondary beam layout over here. So let's unhide this slab over here. Before we unhide the slab, let's select the structural beam system here and key in the offset for the level. Then we can unhide the slab, like so. And we can select everything over here. Filter it, check none. You want to select on levels, structural beam system, column, primary framing, and secondary. So select them. OK. Copy the clipboard over here and copy the assign levels over here, 3, 4, and 5. And that's pretty much it, really. So now let's quickly draw in the shear wall for our building over here. So let's go back to the level 1 plan view. Go to structure. Go to structural wall over here, and let's say we'll be using a 200 millimeter shear wall over here. So let's click from the center over here. Oops, I forgot one thing. I forgot to set the setting to height and set it to level 2 over here. So let's draw in the shear wall over here. And you can select the shear wall like so in the 3D view. And you can copy the clipboard and paste it to 3, 4, and 5. Like so. One thing I forgot to do in the example was to model in the foundation requirements for the shear wall. So I guess we can overlook that for now. So that's pretty much the basics on how to draw in a steel structure in Autodesk Revit 2026. If you enjoyed this type of tutorials, subscribe to this channel over here so that you can stay up to date with more Revit tutorials like this, or perhaps even SAP tutorials one day. Thanks for watching. Have a nice day.